You all to do is just close your eyes. Everybody close your eyes and just listen. Okay, probably don't really understand why I just did that, but the main point was for you guys to tune in and focus on the fact that you all can understand that everybody has the ability to listen and hear sounds. We know this is possible thanks to our ears, but what you might not understand is exactly how our ears interpret sound. My name is Kara, for those of you who don't know me, and for the next 6 minutes or so, I'm going to discuss with you all the process of sound as it travels through the 3 different portions of the ear: the outer ear, the middle ear, and the inner ear. So first, I would like to talk to you guys about why it's so important to have ears shaped in the way we do. Your outer ear, the part that's visible to everybody, is called the pinna. Now, there's a lot of different grooves and notches and ridges and everything, as you can see. 2 of the most important parts is the cavum concha, which is right here, and the sigma concha, which is this line right here. Now, the reason why all of the portions and the ridges are so important is because they're responsible for gathering and funneling the sound into your ear canal. Now, the 2 parts, the cavum concha and the sigma concha, those 2 are important for localizing sounds. And what I mean by that is if you were to close your eyes and I was to clap my hands over your head, you would be able to know that I clap my hands over your head and not behind your head or to the side. So those 2 portions are really important for telling you where sounds are specifically coming from. So the pinna is the first portion of the outer ear, and the second part is the ear canal. I'm sure everybody knows what that is. The reason why there is a lot of important protection purposes to the outer ear, and this is because it's an opening to your body just like anything else. So one of the most important protection parts is called cerumen. It's really just a fancy word for earwax. Everybody knows what that is, probably aren't really a fan of it, but it's actually really important. The reason why it's so sticky is so that way if something was to crawl into your ear like a bug or some small particle, it would stop it from getting farther, because if it did get farther, it could cause an infection or a serious problem to the rest of your ear. Another important protection factor are the hair follicles that you have in there. Same thing as in your nose or in your throat. They're there to stop substances from getting in. The last thing you may not have known about the ear canal, it's not straight. Most people assume it's just straight into your ear, but that's not true. It's actually an S shape. So as it curves like to the right and to the left and to the right again, it's also going up and down. And this is, like I said, for protection, to make sure that nothing can easily get in there. So if you stick a Q-tip in your ear, you're not actually going all the way to in. You're kind of stopping because the curve to it stops anything from getting too far. Okay, so now we move on to the middle ear. The beginning of the middle ear starts with the eardrum. Now, the correct term for the eardrum is actually the tympanic membrane. And the reason why, that's right there, the reason why it's called a membrane is because it's made up of 3 to 4 tissue layers. They're really thin. I can show you guys right here. This is what the tympanic membrane looks like, only this is a much bigger picture. It's really thin membrane, as you can see, really thin. The reason why it's so thin is because it has to be an efficient source for vibrating sound waves as they travel into your ear. So the next portion of the middle ear is, you could consider, the tympanic cavity. That is the whole space where those bones are located. It's really just an air-filled cavity that allows room for these bones to move. So the ossicular chain, that's what comprises the 3 bones. You've got the malleus, which actually connects to the tympanic membrane. You've got the incus, which is on the top, and then you've got the stapes, which leads into the middle ear. Now, these bones are super small. These are the 3 smallest bones in your body, and if you were to take all 3 and put them on a surface of a dime, it still wouldn't cover the surface area. I actually have them on a keychain right here, so I'll pass this around for everybody to see. So when sound comes into the ear, it goes down your ear canal and it hits the tympanic membrane. Like I said, this membrane is very thin because it serves the purpose of being able to vibrate, to send the sound waves farther into the ear. So as the tympanic membrane vibrates, it moves the ossicular chain. So the first bone moves. Because they're all connected, it's like a chain reaction. It just sends the movement and the displacement all the way down to the stapes. which leads into the inner ear. So, as you can see right over here, this is the stapes, like I just talked about. It connects to the cochlea. Now, the cochlea is a big snail-like organ, and this is the most important organ in the whole process of hearing. What this does is, as the sound waves come in and they start to move the chains and everything, the stapes hits the cochlea. Inside the cochlea, there is fluid. And within that fluid, on the surface of the cochlea, are hair cells. And what the hair cells are responsible for doing is changing the sound wave to an electrochemical signal. It's electric because of the nerves that are attached to the hair cells, and it's chemical because of the fluid. Now, I said it was snail-like, so as you can see, it looks like this. And on the inside, it's kind of hard, there's all these little tunnels. So the cochlea just wraps around itself about 2.5 times. So there's a lot of fluid going through and a lot of hairs. These hairs are very, very tiny. So like I said, the stapes moves, hits the cochlea, and the fluid is shifted. Once the fluid is shifted, it makes the hair cells move. It's kind of like if there was seaweed on the bottom of the ocean and the waves move the seaweed, it's like that. So at the bottom, on the surface of the hair cells where they're attached to the cochlea, there are the nerve endings. Now this is where the impulse gets sent to the brain. This is, obviously everyone knows the brain is super complex, and this is where the sound finally gets interpreted. But it's important for these nerves to be connected to the hair cells so that way it can properly send it to the brain. Now I have up there listed, that's the 8th auditory nerve. That is the nerve that is responsible for sending the impulse to the brain to be interpreted. The cochlea isn't the only part of the inner ear. We also have something called the semicircular canals and the utricle and the saccule. These together make the vestibular system, and that's a fancy word for balance. Most people assume that balance comes from a person's ability to see where they are and to use their muscles to stand up straight, but that's not necessarily true. What those two parts do, which are these 3 loops, as you can see in the picture up here, these 3 loops, and then you can't see the utricle and the saccule, but they're connected over here. There are 2 parts within that. So those are responsible for controlling your balance. The semicircular canals, they're arranged to cover all dimensions in space. So anytime you twist your head or rotate it or anything like that, the fluid that's inside them starts to move and it controls your ability to be able to still stand up straight. The utricle and the saccule, those are responsible for linear movement and acceleration. So anytime you go up an elevator or anytime you go, you're in a car and you go really, really fast, you're able to know what that feeling is like because of these organs. That's why they're so important, because you can't just be able to balance without, you can't balance without them. So altogether, it's a very complicated system. Most people don't understand that. They kind of just think, oh, the sound goes in, somehow it gets to the brain, bada bing, bada boom, there it is. But it's a lot more complex than that, and all of these tiny, minuscule little parts are really important for interpreting the sound. It goes into the ear canal, vibrates, it's a chain reaction all the way through. That is how sound is interpreted. And does anybody have any questions? Okay.